Okay, good afternoon, pilot teachers, and good afternoon, students.
Good afternoon.
Thank you. Sit down. Okay, today should see the conclusion of our work on presentation of features mainly found in the last stage of a river valley. Before we go ahead with the completion now of the presentation, I'd like us to recap and look at what we have already covered in the last presentation. And from the last presentation, we were able to look at Oxbow Lakes, their formation, a definition now to help you with what has been covered on Oxbow Lake. An Oxbow Lake is a crescent-shaped lake occurring on a river floodplain, having once been part of a river meander that has been cut through and abandoned by lateral erosion of the banks at the meander neck. That's a definition to what an Oxbow Lake is. If we had to look at a photograph or a picture showing an Oxbow Lake, we have the River Murray in Australia and samples or examples of what we call Oxbow Lakes. The Australians would call such feature a billabong. Okay, stages in the development of an Oxbow Lake. Before we go to the stages, we can also see some more samples of Oxbow Lakes here. Here is an example of one. Here is another example, and another example given out here. On this side also. So for this particular photograph, there are a couple of Oxbow Lakes which have been created. Looking at the development of Oxbow Lakes, it is important for you to be able to identify, number one, the meander. A river has to meander, resulting then in the neck of the land separating two concave banks where erosion is actually effective. This area from A to B is the area where the cutoff is going to actually take place. Concave bank is this bank here, and the other side is this bank here. Note the concave banks, erosion is dominant. Meanwhile, on the convex or the inside band, deposition is actually dominant. The continuous erosion along here and also in this section will, in time, separate a new stream or a new course that the river will take, resulting then in deposition of sediment along the neck of the meander, and the deposition then will cut off the oxbow from a new course or the stream the river has to take. So in time, we can see then the formation of a billabong or an Oxbow Lake. The stages in the development of an Oxbow Lake is important, and for those people who have done the presentations, we'll have the charts available for you to make notes on that information when you go back into your classroom or homeroom. Okay, we also looked at the information on rivers braiding. We were looking at definition as well as the formation of braids or braiding in rivers, and the definition now given from the monitor. Braided streams are streams which are characterized by a network of interconnected, converging and diverging channels resembling the strands of a braid. The whole river system is generally shallow, so that the intervening shingle bars and alluvial material are exposed at low water. In other words, that is simply to do with the deposited material, as explained by the group. The reason for why braiding occurs is simply because of the depositional features, whereby the river has to actually take different courses so that it goes around those obstacles which have been deposited. Braiding is due mainly to the non-coherence of the load, which leads to selective deposition and the subsequent diversion and reunification of numerous channels. So in other words, the deposited materials then will allow the rivers to, or the river to braid into many different tributaries or channels, but later on they can all come back again to one channel and follow it. And as explained yesterday, we were only given an example of the rivers channeling into different areas rather than channeling out and then coming back again. But it was explained well that it is mainly to do with the deposition of sediments that allow for braiding to occur or to take place. Okay, we have some photographs or samples of braiding. You can see here. Obviously, braiding would have taken place as a result of the deposition of materials. Another sample or close-up view of river braiding. You can see the sediments, deposited material here, resulting in the water braiding or taking a different course around the obstacles. Okay, we also had time yesterday to look at floodplains. So if we had to look at the definition of a floodplain, it is simply the part of a river valley which is adjacent to the channel over which a river flows in times of flood. It is a zone of low relief and gentle gradients and may incorporate features such as Oxbow Lakes, point bars, abundant channels, and etc. As explained by the group who presented the work on floodplains, they mentioned also that features like Oxbow Lakes and point bars, levees, and so forth are also found on a floodplain. Okay, we have a photograph here showing us the floodplain. You can see it is this area from where the bluffs are, or the river cliff, from one end to the other end. This whole area here is the floodplain, and that's also the area where the river flows in or flows through. Those features, as mentioned, which are found along the floodplain, I think that has been already explained well enough by the group who did their presentation in the last lesson. Okay, we are going to move on now with the presentation, the rest of the presentation, and now I will call on the group that is doing the point bars to come up and explain what point bars are and also to explain the formation of the feature point bars.
Good afternoon, class. Our group are going to present the feature point bars. First of all, I will define what is point bars. Point bars are features formed in the last stage of a river where there is slow flow of water. Point bars are depositional features formed by deposited of sediments, usually made up of sand or gravel, deposited in the middle or along the banks of a river.
You can tell me and I will come and unpress it for you if you're not sure what to do. Okay. Your t-shirt is hanging on, it doesn't look good.
Bars are formed by deposition when a stream's discharge or velocity decreases. Stream deposits may take the form of a bar, a ridge of sediment, usually sand or gravel, deposits in the middle of a long or along the banks of a stream. During flood, a river can move all sizes of sediment, from silt and clay up to huge boulders, because the greatly increased volume of water is moving very rapidly. As the flood begins to recede, the water level in the stream falls and the velocity drops. With the stream no longer able to carry all its sediment load, the larger boulders drop down on the stream bed, slowing the water, slowing the water locally even more. Finer gravel and sand are deposited between the boulders and downstream from them. In this way, deposition builds up a sand or gravel bar that may become exposed as the water level falls.
The next flood on a river may erode all the sediments in this bar. As you can see from a cross-section of a point bar, this is before when there's no flood. And when the flood occurs, it takes all the sediments downstream. And they may be deposited further downstream and new bars may be formed. Because erosion is dominant on the concave banks, concave banks erosion is dominant, and on the deposition is dominant on the convex banks. Along the banks of a stream, point bars are likely to be formed in the inside of the river channel. The banks of a point bars are likely to occur on the convex banks of a stream river where there are less where there is little or no erosion at all. This diagram here shows a corkscrew motion on a curve which helps cause erosion and deposition. It tends in a anti-clockwise way, depositing all the sediments on the convex bank and and eating away the area where the on the concave banks. Going to a monitor. As you can see, here we have a photograph taken of a river meandering. As you can see, the river meandering and point bars are formed on the convex banks here and here. The next photograph shows a point bar of gravel, consists of gravel which has been deposited on the inside of a cave where the river bends. Thank you.
Okay, any questions for that group? Okay, there's a question here. Where's the other microphone? Yeah.
Why are point bars formed at the last stage of the river?
Point bars are formed at the last stage of a river, mainly because this is where deposition mainly occurs, takes place, and because the water level, water flow is slow, all the sediments carried by the fast-moving water in the first and second stage of a river, they are mainly deposited in the second stage. I mean the
Any other questions for that group? Do you have a question? Okay, if there are no questions for that group, then we'll put our hand together for the presentation. Okay, thank you very much for that presentation. Again, with the work on point bar, perhaps a lot of us know what a point bar is, but the term, we don't know what it is. So with that presentation, you will now know that those materials which get to be deposited mainly on the convex band of rivers, and if they are deposition mainly of shingle and sand, or mud or silt or clay, similar to the two photographs that this group was able to actually show us. Here you see the river meandering and you see the deposition on the inside bank, which is the convex bank. You can also see the deposition on the inside bank as the river continues to meander. On the other side, the convex bank again, the deposition mainly of sand, shingle, mud, silt, etc. They will create the feature known as a point bar. Point bars can actually be formed on the convex banks of rivers, or they can also be formed, especially in the last stage, where the river braiding. Remember the work on river braiding? Yeah, it's those deposited materials that usually allows the river to braid. Those materials, if they're in the middle of the river, especially in the last stage, they can build up sand or clay or silt deposit, resulting in that feature also being referred to as a point bar. They had a diagram here. Had they explained that, you would have understood that point bars are not only formed on the convex banks, they can also be formed where deposition takes place when the river is actually flowing. So here we have a sample of a point bar, a lot of them deposited, resulting then in river braiding around those features or obstacles which have been deposited or laid. Okay, thank you for your presentation. Now we'll move on to the last group.
Good afternoon, class. Our group presentation is based on the formation and processes involved in meandering. But first of all, I'll give a simple definition. Meander is simple, the twist and turn. This part here of a river. Meander is developed when small dips and shallows appear in the stream bed and affect the pattern of the current. Soon, the water begins to swing from side to side, and once it starts to meander, a stream does not stop unless there is an obstacle that prevents it. Thank you.
Explanation on features associated with meander. Meander neck. Meander neck is the strip of land separating one side of a meander from another. Meander bar is this one. It's also called point bars, where deposition is dominant. These two. Okay. Meander belt is the total width across which the river meanders. This one is the meander belt. And the river cliff is a steep undercut bank of a river which is caused by continuous erosion. River cliff is formed along this side. It can be called as a concave bank.
I'm talking about the processes involved in meander. Some of the river deposition like Oxbow Lake and Point Bath can be involved in the process of meander. So this diagram shows the processes during the meander. As the water flows around its meander, it travels faster on the outside of the cup than on the inside because of the greater distance to surface. So greater velocity or speed means more energy. The outside of the cup undergoes erosion. And the deposition while inside of the cup where less energy is available for work, research and accumulation of sediment, that is deposition. The deposit of the inside of the meander is called point bus. So continued moving and stretching of the meander eventually leads to the being cut off and isolated as Oxbow Lake. Any question?
Wait for the question here.
In what stage of a river is a meander found?
Basically, meanders are found in the second and the third stage or the final stage of a river.
Val's got a question, okay?
What causes a river to meander?
As the river flows down, it bounces off the hard rock and erodes the soft rock, and the process continues, which results in the twist and turn of the river or meandering of the river.
Val, does that answer your question? Okay, any other questions? Any more questions for this group? Okay, Susan's got a question at the back. You don't have a question? All of you? No?
Why do rivers meander only on the second and third stage? Why not at the first stage?
It is because of the steepness of the spur or the gradient. That's the answer to your question.
No more questions? Okay, your chat, you'll need. Okay, very good. And again, a very good presentation. And I hope they have answered the questions that you had well enough for you to have understood, or well enough for you to be able to find or know the answer. Okay, we're looking at the monitor. You're looking at an example of meandering. They've constructed their diagram very well here to show what meandering is. From the monitor, you also have a sample or an example of a river meandering. In Papua New Guinea, we have a lot of rivers, and because we have a lot of rivers, most of those rivers will have to also end at the mouth. And through the process or along the way, if you fly over areas where there are a lot of rivers, you will see the rivers meandering, or they tend to actually meander usually towards the final stage of the development of a river valley. So here we have an example of a river meandering. And a lot of those samples we can see mainly when you fly over the Western Province in Papua New Guinea, also in the Sepik area, East and West Sepik, Morobe Province also. Coming back to the presentation, note, meanders are common, as already explained by the group, in the second and the final stage. Not the first stage, simply because of the gradient. In the first stage, the gradient is steep. The water tends to flow a little bit more faster. And the fast-flowing water will tend to erode straight down and also straight on. Headward erosion and vertical erosion is common in the first stage of a river valley. Therefore, because of the sheer weight of the water in the channel, it can actually move and erode straight on. Therefore, the channels, they tend to be straight. We come to the second and the third stage. That's when the gradient becomes less steeper than in the first stage. So the gradient becomes less steeper. What happens then to the flow or the velocity or the speed of the water? It also decreases. And if it is going to decrease, instead of cutting straight on now, it will not have that power or force. Therefore, it will tend to cut the rocks which are softer more than those that are hard. So it starts to twist and turn to follow those soft rocks when it is cutting, and that's where we have meandering starting. Okay, with all the presentations now, I would like you to put maybe a big hand together for all the presentations, because this will also conclude the work you have been doing on presentations on features, mainly on the last stage. And I would like to say that you have done a very good job in the presentations, and I hope those who are watching can also learn from what you have presented for them. Well done, and we put a hand together for a job well done. So to summarize and to finish off what we are doing, note, most of the features that we have looked at are basically features of the last stage of a river valley, excluding the canyon and the gorge plus the plunge pool. They are features to do with the first or the second stage of a river valley. Those are not the only features that you can find in the development of a river valley. There are other features such as the river cliffs and the slip-off slopes and the bluffs that we have left out. But it is also important that those features, we get to know about them. So whatever we have not covered in grade 11, we'll try to actually fit it into our program in grade 12. There might be some students who might have maybe some questions to ask generally with regards to what we have or what you have presented, and perhaps I'll allow 5 minutes or time for that now. Any questions, general questions that you'd like to ask, perhaps with any of those features that we have looked at already in the development of a river valley, especially the last stage? Christopher has a question.
Referring back to point bars, is it possible the formation of point bars can enable the formation of Oxbow Lakes?
Can be involved?
Enable the formation of Oxbow Lakes?
Oh yes, definitely. If we come back to looking at that photograph, obviously, because remember when we are looking at rivers meandering, when a river meanders, there is evidence of erosion on the concave bank. It is the concave bank when one neck of the meander meets with another neck that it will cut off the feature which is known as an Oxbow Lake. Meanwhile, always when there is actually erosion on one bank, there will always be deposition on the other bank. And that's where you have the formation of point bars. So definitely point bars are also involved in the formation of Oxbow Lakes. They are deposited materials which silt up the area separating an Oxbow Lake from a new course that the river has to take. For those who are thinking point bars are only found in the last stage, point bars can also be found in the second stage of a river valley, especially where the meandering of a river begins. Because when a river meanders, there will always be a concave bank and there will always be a convex bank. And it is the convex bank that deposition takes place, and that's where we can have point bars. Gideon has another question.
Referring to the river mouth, why is that they are not like build-up land, especially mountains or hills, from deposition of materials, all the materials that is brought down from the second and first stage of the river? Where do they get to be, like over thousands of years? Why is that there's not like mountains formed at river mouths or something?
Okay, good point. Well, Gideon is wondering why is it that at the mouth of the rivers we're looking at depositional features, and why can't depositional features form huge mountains? We looked at tectonic forces, and we've looked at the study of plates coming together, moving away from each other, etc. The formation of mountains and hills and plateaus especially are mainly to do with forces which are tectonic or tectonic forces. Here we are looking at denotational forces. Most of the denotational forces are to do with the lowering. It is only the deposition which is not part of denudation, because it does not uplift the land so high up above. Those materials that get to be carried out to the mouth of the river, they do not just stay there and accumulate and build up and build up and build up. No. The force of the water will finally take them out into the sea. And remember, the sea has currents. And the sea will also contribute to the movement of those deposited materials elsewhere. And that's the reason why you don't expect them to be there and stay stationary, like in the tectonic movements where there is uplift. And then perhaps if the forces stop because the plate boundaries might have shifted or moved, then you already have the high elevated areas which have been formed through that process. But whereas for the rivers continuously flow. They flow out to the sea. Finally, where the big rivers end out at sea, the current in the ocean will always continuously move, resulting in the picking up and the transporting of those sediments which have been deposited elsewhere. So therefore, the areas which are built up do not get to be built up as high as the hills or the mountains. Does that answer your question? Okay. Any other questions? Okay, Val has a question.
Could you explain on Panoplanes what stage they develop? I mean, compared to floodplains?
Okay, Panoplanes. A panoplane is simply a term that we use to describing the almost flat and level area. Panoplanes would usually start off, if we are trying to look at the stages in the development of a panoplane, we'll start off with high elevated areas. Because we are looking at a panoplane, we have to look at rivers. Rivers contribute to the development and formation of a panoplane. So we go back to the start of that river, the source of the river, and we will find that if we are studying a particular area which is almost flat due to the erosional and transportation and the deposition of materials, then looking at river studies, we go back to the high elevated areas. The high elevated areas, over time, the work of rivers cutting down, cutting across will continuously lower and lower the land until we come to an almost flat area, of which that flat area then becomes a peneplain. But we have to understand that we're looking at geological time, we're looking at millions and millions of years for that process to occur. You do not get up tomorrow and today you see high mountain areas and then tomorrow you see the work of rivers flattening that whole area. Impossible. Rebecca, you have a question? Okay, perhaps we'll make that the last question also for our lesson today. Ovio, you want to ask the last question? Okay, that's the second last. Second last, and then Ovio will have the last question.
You were just talking about tectonic movements. I was wondering if, like, when there's a tectonic movement and it forms mountains and stuff, we know that it will alter the flow of the river. And what I'm asking is, does the river like cut off, or does it form different features, or what happens to the river when it's cut off or something comes in between it?
Okay, when you have looked at the work on canyons, remember the students mentioned that canyons can also be formed as a result of the uplifting. The uplifting then can contribute to the sides of a river valley becoming very steep, resulting in a canyon being formed. Or if you have a waterfall, and there is a plate boundary or say a fault line that occurs resulting in one area, I'm sorry, I should not say a waterfall, let me say a river flowing, and we have perhaps a fault line in between, then if one area is actually lifted and the other one is depressed as a result of the tectonic movements, then you will see a waterfall is likely to occur. Let's go back to perhaps what we have covered on the St. Andreas Fault. There was a picture or a photograph I showed you on the changing of the course of a river because of that fault plate movements sliding past each other. So once upon a time, the river was in a straight course, but because of the fault, one bank of the river has actually been moved and forward, the other one back, and now the river has to follow a new channel or course because of the tectonic movement. So definitely plate tectonics can alter, and they can change the course of the river. They can also change the height of the river, and they can also contribute to features such as rapids and waterfalls to also develop. And the last question then from Ovio.
This is a general question, like if there's more deposition of sediments on the sea, is there a possibility in like the decreasing of the volume of the sea or water?
No. The amount of water we have on our planet Earth is actually fixed. It's through the process of the water cycle that the water gets to be recycled over and over, but the amount of water we have here is fixed. So if you put a lot of sediments into the water, especially if we're looking at, say, take for example, the Fly River, and we're looking at mining. A lot of sediments down the river as a result of maybe excavating and mining, blasting and all that at the top can contribute to sedimentation and siltation of the bank and the river, resulting then in the decrease in the amount of water which is flowing in a channel. So once upon a time, you might have a wide channel, water flowing. Because of siltation, deposition of sediment, the channel gets smaller. It can also contribute to the reduction of the amount of water which is actually flowing in that particular stream or river. So it does not, just because of sediments, it does not reduce the amount of water in the oceans and all that. No, the water on the surface is fixed. But it will contribute to lowering the level of water perhaps in a particular channel, or it can overflood a particular river bank depending on what type of activity is being carried out there. Say if we have a dam the Colorado River, there's a lot of dam which is built along that way. Even if we're looking at Sirinumu Dam, which has been built, you will find that perhaps at the first stage, above the dam, flooding is possible when there is heavy rainfall. Below the dam, the level of the water in the stream is actually decreased. So these are some of the effects that can occur as a result of perhaps interference to the flow of the river in a particular channel. But definitely, yes, interference on the flow of the river can have an impact on marine life. It can also have an impact on velocity, discharge, speed, etc. of the flow of the water. And I did say that was the last question. Perhaps maybe later on, if we do have other questions, we could ask when we are given the opportunity to do so. Okay, class, that will also bring us to the end of our lesson. To the pilot teachers, our keyword for lesson 80 is river bluff. Good afternoon, and thank you, class. Good afternoon.